and welcome. In this video, we're going to talk about domain and range, and specifically how they relate to graphs of relations and functions. I have a separate video about domain and range with tables, and here we're just focusing on the graphs. So we say that the domain is the set of possible inputs of a relation or function, and the range, sometimes also called the codomain, is the set of corresponding outputs of a relation or function. So domain is the inputs and range is the outputs. When we're doing this on a graph, since the domain is the inputs, this would correspond to the x-axis. Because of this, we would look for intervals going from the left to the right. So the domain is going to be an interval of values that correspond to inputs on the x-axis. Similarly, with the range, we would look at the y-axis since this corresponds to the outputs. So our range would be an interval and we'd go from bottom to top. So we're going from least to greatest in that way by starting at the bottom of the y-axis and going up to the top. When we have tables, the domain and range are sets where we have just a list of values. But now that we have relations that are represented with graphs, we have something continuous, and so we need to use an interval since it has an infinite amount of points that we're looking at. We can't just list them out. We need to use an interval to represent them. So let's do some practice with this. Just remember domain is the input, so we'll look at the x-axis for those, and range is the output, so we'll look at the y-axis for those. Let's find the domain and range of the relations represented in the following graphs. So I'm going to have 3 graphs for us here, and we'll just do one at a time. So looking at the first graph, let's find the domain and the range. Just as a note before we get started, you'll see that this is a function since it does pass the vertical line test. Every input has only one output. So for the domain and the range, we're looking for where the values exist on the graph. So for domain, I'm going to think about reading the x-axis from left to right. And I'm looking for which inputs, which x values, have corresponding outputs that are on the graph. And so whatever inputs are possible, meaning they actually correspond to the graph we're looking at, those inputs are things I want to include in my domain. So as I start on the left, you'll see that these values don't have any outputs. So these inputs aren't in our domain. There's nothing on the graph over here at this part. But then once we get to -1 on the x, we start to actually be in the territory of the graph we're looking at. So x as -1 has an output of -2 on the y. So this is where our domain begins. So we're starting at -1 for our interval, and we're going to use a closed bracket since there is an output at -1. So -1 is an input of this function, and so it will be in our domain. Now we're just going to continue going to the right. All of these input values here correspond to points on the graph. So we're good, we keep going to the right, and you'll see that actually since this graph continues on forever, everything as we go to the right continues to be in the domain. There's never a value we're going to get to that doesn't have a corresponding output. So we're going to infinity on the right side of our domain. As an interval, I would write this as -1 to infinity, where that -1 has a bracket on it. And remember, we have a parenthesis on the infinity. Since we always use parentheses with infinities, it's not really a place we can get to, it's more of a concept. Okay, let's repeat this with the range. Remember, the range is the y-axis, and our solution again will be an interval. So we're looking for y values that have points on the graph. So as we start from the bottom and work our way to the top, you'll see that the first values we're looking at aren't on the graph. But once we get to -3 on the y, suddenly we are starting to hit the graph. We have points on the graph. So this is where our range is going to begin. I'm going to use a bracket since at -3 there is a point. Our point is 0, -3. So -3 is in our range, and that's where I'm starting my interval. Then as I continue to go up, we'll see that all of the y values going up have corresponding inputs. They're all on the graph. So since the function continues on forever, going up, we're always going to have y values that correspond to inputs, and so our range is going on to infinity. So as an interval, we would write this as -3 with the bracket to infinity with the parenthesis. And there we go. Those are our domain and range. So for domain, we look at the x values and see where they have points on the graph. And for the range, we look at the y values and see where they have points on the graph. So this can be hard at first, especially if you're not used to it. This is a different way of thinking about things, but we'll be practicing this here. And then as we continue to learn more functions, we will be practicing this again and again as we do more functions and look at more graphs. Okay, so let's repeat this on our next graph. So I want to do the domain first, so I'm going to look at the x values. Again, I read from left to right, and so I'm going to start until I reach a point on the graph. So I don't have any points on the graph until I get to -6, and that's where the points begin. So at x equals -6, I do have an output, and so that is in our domain. So my domain starts at -6, and I'll use the bracket since that point is in the domain. We want to include it in the interval. Then as I continue from left to right, all of these input values have outputs. They're all on the graph until we get to +6. This is the last place where we see a point on the graph. So anywhere to the right of 6, we don't have any outputs that go with it. So our domain ends at 6. This means our domain is from -6 to 6 with brackets on both parts of the interval. This is because both -6 and 6 are valid inputs to our relation. They both have output values that we can see on the graph. Okay, so our range is going to look similar. Remember, we start from bottom and work our way up. So as we work from bottom to top, at first we don't have any points on our graph, so these values are not in our range. But then once we reach -3, we do have a point that's on this graph. So this is the start of our range. Then as we keep going up, all of the values above -3 continue to have points on this graph until we get to +3. And remember, we're on the y. So when we get to +3 on the y, this is the last location where we have a point on the graph, and then anything above that doesn't correspond to a point. So our range would be from -3 to 3, and we'd use the brackets since we do want to include -3 and 3 in the range. Okay, let's try this one more time. So let's find the domain and range again. We start with domain, reading from left to right. I see that my graph does not start until x equals -5, so this is the first value in my domain. Then my x values continue until I get to x equals 1, and this is the last place where I have a point. Something unique is happening here where we have this open circle. This represents that 1 doesn't actually have a value at 2, it's like a hole in this graph. So we have everything up until the point 1, 2, and this means we're going to use a parenthesis for 1 in our domain. So we have -5 with a bracket, but then we're going to do 1 with a parenthesis to represent that open circle. Okay, let's repeat this for the range. We see on the y values reading from bottom to top, we don't have any points until we get to about -0.75. That's the first value where we have points on the graph. Then this continues all the way up until y equals 2, where we have that final location on our graph that corresponds to the point 1, 2, which is actually that hole or that open circle. So as an interval, we would write this as -0.75 to 2, and I would use the bracket on the -0.75 since that location actually does have a point on the graph. But I would use a parenthesis for 2 because when we get up to 2, we have that hole in the graph. So we're including everything just up until that value. And there we go. That's our domain and our range. All right, so that is how we find domain and range with graphs. Remember, this can really be challenging at first, so just be patient with yourself as you're doing this and continue to get more practice as we learn more about functions. Thanks so much for watching, and I will talk to you in the next one.